Hi everyone, my name is Bae Yong Pui, and today I will talking about the behavior of light in relation to the eyes. This topic is very important in physiological optics because it helps us understand how light interact with the different part of our eye to make vision possible. We all know that light is essential for vision. Without light, we simply can't see. Our eyes work kind of like a camera. Light enter, get focused, and form an image on the retina. In this presentation, I will walk you through how light behaves inside the eyes, how it bend, pass, and focus, and how this process relate to clear or blur vision. Before we talk about the eye itself, let's quickly go over the basic behavior of light. These are four main ones. First is reflection. When light bounces off a surface like a mirror, then reflection when light bends as it passes from one media to another, like from air into the cornea. Then absorption, when light energy is taken up by a material and may be turned into heat. The last one is transmission, when light passes through something transparent like the cornea or lens. All of this happen inside our eye, so understanding them help explain how vision works. Now, how does light actually travel through the eyes? It starts by entering through the cornea, then is moved through the aqueous humor, pass through the pupil and lens, goes through the vitreous humor, and finally land on the retina. Each part play a role in bending and guiding lines so the image focus correctly. The cornea is like the main focusing window of the eyes. It provides about 70% of the eye's total focusing power. Because of its curved surface, it bends the light ray and help direct them into the pupil. If the cornea isn't perfectly shaped, for example, in astigmatism, the image become blurred or distorted. Next, we have the lens. The lens work together with the cornea, but it has one special ability. It can change shape. This process is called accommodation. When we look at something near, the lens becomes thicker. When we look far away, it becomes thinner. This change helps us focus at different distance, just like adjusting a camera lens. We also have two clear flow that light pass through, the aqueous humor and the vitreous humor. The aqueous humor nourishes the cornea and lens and maintain pressure in the front part of the eyes. The vitreous humor, which is more gel-like, fill the back part of the eyes and help maintain its round shape. Both are transparent, so light can pass through easily to reach the retina. Once light reach the retina, it finally form an image. The image that formed there is actually near and inverted, like upside down. Our brain flip it the light way so we see things normally. Inside the retina, there are photoreceptor, like lobe and cone, that change light into electrical signal, and this signal travel to the optic nerve and then to the brain. Now, the most important behavior of light in the eyes is refraction, the bending of light. Refraction mainly help at 2 points, the cornea and the lens. The cornea has a fixed power, which while the lens can adjust. When both work perfectly together, light focus exactly on the retina. But if the light focus in front or behind it, that when we get refractive error. Sometimes Light does not behave perfectly, and we get some interesting optical phenomena. One example is dispersion, where white light split into different color, like what happened in a rainbow. Another is aberration, which are small imperfection in how light focus. There are two main types. Spherical aberration, where light ray at the edge of and center don't meet at the same point. Chromatic aberration, where different color focus at slightly different spot. These phenomena are similar in the eyes but still important in optical science. When refraction does not happen perfectly, we get refractive error like myopia, the image formed in front of the retina. Hyperopia, the image formed behind the retina. Astigmatism, caused by uneven curvature of the cornea or lens. Presbyopia, which happens as we age and the lens lose flexibility. And all this can be corrected using glasses, contact lenses, or refractive surgery. Understanding how light behave is super important in optometry. It helps optometrists find out what kind of refractive error a patient has and how to fix it. By studying the optic of the eyes, we can design better lenses, treat visual problems, and help people see clearly again. So, to sum up what we covered today, light passes through several transparent structure in the eyes. The cornea and lens put together to focus the light on the retina. The retina changes light into signal that go to the brain. And any problem with low light is focus causes blurry vision, which we can correct using optical methods. Understanding the behavior of light help us provide better eye care and improve vision. That is all from me. Thank you so much for listening. I hope this help understand how light behave in the eyes and why it's such an important topic in physiological optics. Thank you.